Perfect. Yeah, I'll drive it up. I got to see if I can even get it through there. Awesome, man. I sure appreciate it. Yeah. Try not to get overheated today. Yeah. Thanks, man. Welcome back to the channel, everybody. We are ready to start a new series. This one is a little bit of a departure for us. We've been building spec houses pretty consistently for the last, 2017 I think was the last custom we did. But this is a custom project, but not just any custom project. It is a little accessory dwelling unit. And right off the bat, we are running into a problem. Can you guess what that problem is? I know exactly what the problem is, even though I was extremely clear with all parties involved. Permission to vent. Yeah, we showed up at the site work. We were not involved at the site work, and I made it abundantly clear I needed 14 feet. I was given 9'5". Thankfully, the forklift has four-wheel steer, and I can get in there. However, it has been nothing but challenges ever since. If we jump ahead, we had to get truss delivery, and we had to drive it up the driveway because there's no chance of getting a boom truck up there. And of course, when the truss company is supposed to be there Friday morning, and then Friday at noon, and then Friday at 2, and you keep calling and they show up at 3:30, and now everybody's on overtime, well, it costs us a significant amount of money now to do everybody else's job, all because the homeowner wanted to save a few dollars and not move his tank. He's going to end up moving that tank, mark my words. This is a 1,200 pound or 1,500 pound girder truss, 10 foot high, 42 foot long. Again, you can see the issue. Bringing it up the driveway. This part here, I'm just showing you because it's kind of cool. We knew that was going to happen, but we could have done that with the boom truck. Anyway, I am not complaining. The wall on the left there has lots of rubber on it. The tires on the left there have lots of wall on them. Anyway, let me show you just how tight this is. It isn't the end of the world, so let me just say I'm not complaining about that. However, now as we've gotten into the project, we have spent a significant amount of time. What they should have done is take that bottom septic tank and moved it to the left and up. I guarantee you that's what's going to happen when we're done. But hey, the framers, because they're super attractive, they can handle anything. Oh man, that's great. Hey, who wants some good news or even gooder news? So when we got to the job site, I measured it, and we've got about 2 inches on each side. So hey, we did it. What's up? So I don't think, we just squeaked through. And so it gets bigger there, but you can kind of see way down there, that curve. That's what the issue was, but we did it. And so what I'll probably do is I brought the bigger machine so that we could actually pick lumber. We might still end up moving some block, but we'll see. That is good news. And that's why they call me the eternal optometrist, because I always see the glass half full of beer or high quality whiskey. So anyway, yeah. Even since then, we've made it work. It's a mild hassle, but at least we got the machine in there. So this is a good start to this project. Not a lot of room, and the septic reserve is up above, kind of where the camera's actually stationed. So we could set material on there, but we really couldn't operate on there. That machine, by the way, is 33,000 pounds, I think, on the stamp, and I can't remember. We're getting close to replacing the tires. They're foam filled. I was talking to the mechanic today, actually. And we just couldn't remember. We just remember it was a lot of foam that went into those tires all those years ago. 2005, the fall of 2005. You know, if I think about this for any length of time, I've been doing this maybe just a little too long. Enough of the complaint fest. Okay, so we were not involved in the scope of work for the site work or the concrete. Or the engineering. This is like, we have some stories to tell as we go through the project. So you're definitely going to want to watch the whole project. The foundation sub decided to do this all mono. As you can imagine, mono meaning pour the footings and the stem walls at the same time. The engineer, however, must have just hit a button on the keyboard because we literally had bolts every 16 inches. So we had to adjust the layout a couple times. Anyway, we're going to come back to that. We'll just see if it's close enough to 30 feet that we don't have to fudge one or the other side. I'm gonna hop in. And I think if you just hook concrete, that'll be good enough. Okay, so I'm real close. You know, I'm within a quarter. So I think if we go to the other end, yeah, snap the back 5.5. And I could hook it and pull it up in both sides. I like it right there. I was taught to never hook concrete, basically, but put the 5.5 on the 5.5 line that we snapped. That one looks like it was just a little bit off, though. Usually the corners are the best braced, too.
This wall here is pretty wavy.
Yeah.
Down it.
They poured it mono. It's just harder to keep it. Okay, so I'm going to go 30 foot minus 5.5, 29 foot 6. I'm going to keep the tape up high. So I got 29, 6.5. Then we'll go down and mark the other side. So you're tight. I am 29, 6.5. Okay, you like it? Can you do 3 at a time? I can do 2. It was a trick question. Now I don't have to supplement with iron.
Yeah, so bad.
Just go right through my skin. Yeah, I read in the shear wall book, he also addresses not going more than a 16th oversized.
Oh, on the bolts?
Yeah. If you do, and I don't know if because, you know, if it's 5/8, it would be 11/16. So that's not, it's not like there's a full 16th all the way around. It's really just a 32nd.
Yeah.
But I don't know.
3/4, what you're saying?
Yeah. Because then you would have a 16th all the way around. But they say that it causes slippage. Okay, I think that'll work. Especially if you use the side of it. I'm going to circle back around to what I was just talking about a little bit later when we're actually marking out anchor bolts. Almost all of you that are listening, you're drilling the holes too big, technically. Does it really matter? That's what I was trying to get an answer to. I'm still trying to get an answer to that. But anyway, there's the NDS reference. That Dude Tools or a Burke bar, any pry bar will work to straighten out the bolts. Doesn't take that long. Ooh, that is nice looking stuff. How come none of the rest of our lumber looks this good?
You built up here before?
Nope. I have never been up here before. My grandparents in the early 80s lived just down here on Chico by the water.
Oh, yeah?
Stuff's nice and light. Okay, anchor bolts. Max 9 inches from the end, that's interesting. Okay, 7 diameters from the end, 4 diameters from the edge. So 7 times 5/8. So 4 3/8 is the closest that the bolts can be to the end. There's no way I can really get that. So I guess I could if I go this way. Do I have enough? So I'll just put a mark here. 4 3/8. I'm just going to go from the edge. 4 3/8. So I guess this would be the one to do it. That's the minimum. So I'm okay there and I'm hanging out. There are a lot of ways to mark anchor bolts. I find that if I set the wood close by, and by the way, that is 3x6 bore 8 treated mudsill. Those are called incised marks. Literally, the treatment is forced into the wood through those marks. That's why it's called pressure treated. I find that if I just eyeball the center of the bolt, so you can see how that mudsill, both sticks are just leaning. They're pretty close to the bolt, and I'm just using my eyeballs because they have been calibrated. Once I have centers marked, then I go ahead and I scribe a straight line across. Are you with me? It's not rocket surgery. This is just the most accurate way that I have found, and I'll prove it to you. There's that nice blue line. Now the next step is I'm going to measure off the line to the center of the bolt. That line represents the inside edge of the mudsill. And so I go ahead and I just transfer each one of those. And I'm trying to eyeball this pretty tight because as I was just mentioning, these are 5/8 bolts, which means code allows us to use a maximum of 11/16 for the drill bit. Yeah. And so when you have an anchor bolt every 16 inches, right, it would be so much easier if we could just drill 3/4 like we used to when I was taught in the 90s. Then we started to read the code and we started to get more engineering. So 1/16 is the oversize, the max oversize. I was taught to use a 3/4 inch bit and to ream the hole, meaning kind of swing in a circular motion the drill bit. And I'm going to show you here in a few minutes why I really do prefer that. So as I'm drilling this, let me just tell you a backstory. I talked to our local Simpson Strong Tie rep. Where does the 16th, 1/32 to 1/16 come from? And so internally, they just sent me that NDS reference, which was really helpful. But what I'm looking for is, if we drill just a little bit bigger, does that really have such a negative effect as compared to beating down mudsill that is so tight? Let me show you that, and what prompted my question. Just watch how much work it takes to line up all these bolts. You can see there, some of the bolts stayed relatively in line. The wall itself wasn't particularly straight, but it wasn't terrible. But we have anchor bolts every 16 inches, plus we have hold down bolts, which stick up just a little bit taller. The best way to beat the mudsill down is not with your hammer, but it's with a maul of some kind. And the reason I say that is you'll cause less damage to the sill.
Hey, that's right on the line. Go figure, man.
And just to prove it to you, that is as straight as we're going to get it. And actually, the treated looks pretty good. So, second piece. Incidentally, you might be wondering, why did I run it out long? Notice at the far distance, it's hanging out. Well, I'm going to show you that when we square this up. Basically, we wanted our sill in the front and the back to be exactly 30 feet outside to outside. We have not yet pulled square. And so by running these long, it'll make it easier to pull square. So again, as I'm mentioning, really the genesis of my question to Strong Tie was, we go to all that work to drill nice and tight, but then we have to beat that stuff down. Doesn't that have a more negative effect than if we just oversized slightly? If you are an engineer, please let me know in the comments. Inquiring minds want to know. Actually, I think that's a really good question. So I'm gonna actually reach out to some engineers.
We're gonna go right to left. Oh, they're real close. So I'm marking 30. Gonna square it off. Sorry, thing's locked. Okay, so 42 foot, 5.5. "42 foot 5.5 is right there. I don't think I care for that. Let me go this way. Yeah, it really needs to be this line.
This was just a dumb way to do it. Just a dumb way to do it. I thought I could hold the square on like diagonal, like underneath the tape, and it would work. I should have just used the plum dot. Plum dot millionaire. It's an Austin Searstad reference.
Yeah, I gotta hold it square both ways. 5.5 is right here. And what I'm gonna do is try to go parallel. Yeah, come on, Timmy. Okay, that knot is making it rock and roll. Come on, man. Okay, I'm just lining up the square. Yeah, I mean, I think we're right there. Going both ways. I can't really tell. This isn't that great of a way to doing it, apparently. 42 foot 5.5. Yeah, I mean, I think we're right there. So their foundation's within a quarter. So their concrete is actually, let me see that. I would say that that's pretty good. Where's the square? There it is. Yeah, okay. Let me put this back. So on your end, whatever your mudsill thickness is, I'm 5 and 10, is let's just go back 5 and 5/8. And that's what will snap. Yep, and then if we hook, I actually have a chalk line. I don't know, I found it yesterday, so it must have been Kyle's.
No, that's mine.
Oh. Well, that's perfect for this. So yeah, if you hook there, then I'm just gonna hold it to the edge here. And then if you mark, I can come down a little. Tell me when I'm just above the concrete.
You got a ways to come.
Okay. I just go with that. I think you can eyeball that through. And you could even use your square. It's probably quicker. Okay, and I'll go. Giddy up.
That's why we left it long. Now we can cut it off and then pull 30 feet, and we're exactly 30 by 30.
30 foot. Okay. So this side misses, but I don't really care. Then I'm gonna go ahead and come back 5 and 5/8, which is almost where that bolt is at. Yeah, I kind of think let's do this. Well, shoot. Well, whatever. I'm just not gonna hit concrete on this end. So it's a little bit off.
Let's see if I can clarify this a little. We have a 30 by 30 square. We snapped 5.5 in on each end, snapped a line across the back. Then we hooked our tape measure, burning 5.5 because I don't like to hook concrete. And we pulled forward. Come on now, let's go 11. So we burned 5.5, pulled 30 feet minus 5.5. So that's 29 foot, 6.5. Do that at each end, snap a line, install the mudsill. Just the way it worked out with 16 footers is they each hang off about a foot. Okay, we picked this corner over here as the arbitrary reference corner. Cut that off. 30 foot rise, 30 foot run gives us a diagonal number that we swing as an arc, and wherever that crosses this outside line, that now locates 30 foot by 30 foot with a perfect square. From there now, we can pull across 30 feet, and now we can cut off all the ends. And of course, from this reference point, we would pull here and go 30 feet. Of course, we snap inside lines, but that's the reason why we did it this way. Is then we have something to hook. Often, especially if I'm doing layout by myself, I will install at least the one reference piece of mudsill because then I can hook my tape to that. So hopefully that's clear as mud. And then of course, because there were step downs, what I should have done is in this bottom left corner, should have just shot a laser up, but woulda, coulda, shoulda. I think that's a Taylor Swift song.
Code requires 1/2 inch bolts at every 5 feet. An easy upgrade to get a little more strength. In the one engineering book, he's like, it's like nothing. So just go to 5/8. If you want to go beyond. In this case, the engineer must have calculated we needed 5/8 on 16-inch centers.
Yeah.
Okay, that's like you'd see that at the coast. We'd go through some of those houses, big hold downs, and that's because of the wind loads are so much bigger than here. You know, we're up high. There might be wind loads here. I don't know. That could be part of it. We went to, in Portland, we went to the museum, science, whatever it is. You could stand in a machine and it simulated the Nagasaki earthquake, I think the Northridge earthquake in California, and you're standing in there. And the thing, you're just like, all right, everybody hold on. And then when it shakes, you're like, oh, it's just like this. This is all it is.
Yeah.
But then as soon as the building's taller, it whips, right?
Yeah.
So this being a one story, it doesn't get that. But when you're sitting there, you're like, oh, now I understand the structure can't slide off because of the anchor bolts. My chalk line meaning your chalk line that I stole.
Well, ultimately it's your chalk line.
Okay, so I will go till we're just above the concrete.
Yeah, you're just above it right now.
Okay. I don't know. We'll see. It could be when we're done today that if there is anchor bolts that need to be drilled, then you could always come up and drill them before and after.
Yeah.
And we'll know. You get it? Yeah, we can make that work. And I'm gonna mark, yeah, so I'm gonna mark 18 and then we'll make an adjustment. There's a little bit of a discrepancy on the plan. And we'll go down on this end. The truss company just rounded to 18 foot for their bearing. And so we're gonna do that. Okay. If the truss company showed 18 feet, then I'm gonna go 18 feet. Go for it. Okay.
That is a Diablo grinder wheel attached to the grinder. What I am cutting is the Ufer ground, but it has that nice, beautiful candy cane shape to it. I don't know how to get a piece of 3x Mudsill cut drilled 1/16 bigger than the bolt diameter up and over that. Incidentally, the threaded rod to the left and to the right, you see it sticking up back there, that is for the hold downs. And then, of course, that's also the other end of the Ufer ground right in front of me, that piece of rebar. What is a Ufer ground? Well, you can read it right there on the screen.
All right, 56 shy.
Bet she thought I was going to hit the concrete. Here's a pro tip for you. Notice the dish soap in the foreground. Put that on the bolts. It's supposed to make the Mudsill slide in a little bit easier. I did not find that it worked, but maybe I did it wrong. I'm kind of notorious for doing things wrong. I'm using like the speed bore bit from Diablo. We get them at our local lumber yard. They're fast, speed bore bits. It's a spade bit. I've been told auger bits are better. I don't know if that's true. We've used either or. These are inexpensive and fast, so I just buy them down at the lumber yard. I guess post in the comments below if you strongly feel there's a benefit to one or the other. And here we go with the dish soap. A little squirt on there. I mean, these bolts hadn't been there that long, maybe 3 months before we got there. But yeah, they're rusty. They weren't galvanized. And they don't need to be with the borate treated Mudsill. But as you're gonna notice, I just didn't find that it helped lubricate anything. So is there a better product to use? Again, leave it in the comments. We can all benefit from it. If we're not supposed to drill more than a 16th oversized, then we need something to help us along because we don't want to break the Mudsill. And it's very easy to do. Also, don't pinch your fingers. I know a guy that did that a minute ago.
Really?
A few people on Instagram commented, hey, what is the deal with the vents there? So the homeowner decided to have the foundation guy go ahead and do concrete pony walls. And then of course we had to frame little 1-footers. He was very concerned about venting, and so that's why he just had him throw some vents in. You've got the giant crawl access hole, but you know, it's what the customer wants. Incidentally, if you were going to use an impact driver, finger tight plus 1/3 to 1/2 turn. So you'll notice that as I drive it down, once it goes snug and just stops, that's when I stop. Don't over tighten the bolts.
Hey Brandon, beer me a standard washer.
Washer or bearing plate?
Washer. Oh man, I thought I missed it. Okay, so you're probably used to bolting down your mudsill with just standard round washers. That's what we used to do. Starting in the early 2000s, the International Residential Code required that we use 3x3 bearing plates, and the code requires them to be 1/4 inch thick. I think specifically chapter 6 says 0.229 inches thick. This is the Simpson Strong Tie 3x3 bearing plate that actually is a 1/4 inch thick. So if you ever needed it for a shim, 1/4 inch. This is the slotted version, meaning that we can adjust it to get it more centered on our mudsill. And when we do that, then of course we do in fact still need to use a standard round washer. In our trailer, we've had a bunch of bearing plates that we just order. These are generics. So I have 5 of the generic bearing plates, 3x3, 1/4 inch, right? I'm just gonna show you the difference. That's 5, 1, 2, 3, 4, and 5. So it's 5 and 5. This is a code 1/4 inch bearing plate. Notice the difference. It's almost like we would have to take 6 to make the same thickness. So if you're buying imports, just recognize, make sure that you're meeting the code. And for us, we're just gonna use the Strong Tie. Now this house has been a lifesaver to use these because the engineer wants them centered on the mudsill. This is the worst anchor bolt job that we have ever shown up to. And no, Austin Framers did not do the foundation this time. We would have been drilling in Titans if that was the case. Anyway, slotted bearing plate gives us some flexibility. There's your round washer. And basically, like, what's the purpose of the big bearing plate? It more distributes the load on the mudsill, and so it's not gonna break. And if you've ever had the experience tightening these down, even by hand, you can basically tighten this right through the mudsill. You can't do that with these.
Let's just do a quick sneak peek. It's a 30x30. We've got bonus room trusses. Then we have the porch. We went with wraparound. Well, it has a wraparound porch, but I was able to work with Roseburg on full length. These came out at 48 feet. Wait till you see the drone footage of getting those down the street and up the driveway. Anyway, we're gonna get into all of this stuff as we roll through this project. I have to say, if there is a massive earthquake, the people who will survive it will be the people living in this structure. It's been an interesting project to say the least. Hey, thanks for following along. We'll see you all in the next video. Hit that like and subscribe button. You know you want to.